Okay, now we have the newest form of categorical data display. It is a mosaic plot, and this was actually added into the AP Statistics curriculum in the fall of 2019. However, due to COVID in the spring of 2020, we were unable to assess this on the AP Stat exam. It is something that we have to know how to use and how to navigate, and it's actually quite fun once you understand what it means. So, for example, let's say Mr. Pinto is surveying teacher and student opinions on favorite class subject at school. So Mr. Pinto interviews 100 teachers and 500 students. Okay, so let's say of these 100 teachers, and y'all, I'm going to keep it pretty simple just for the sake of display and example. Um, Everybody loves math, so let's say that 50 teachers love math, or think that math is the best subject, because it is. Then let's say that another 30 teachers said, nah, the vote's for English. And then lastly, the smaller group here, the last 20 teachers say, actually, electives are the most important. So then Mr. Pinto goes and asks students the same question. And students say that for math, well, actually, only 200 students prefer math. For English, maybe it's only 150 students. And then for electives, that would be another 150 students. So I see 50 plus 30 plus 20, 100, 200 plus 150 plus 150, 500. So the categories seem to differ here, right? I have 100 teachers, I have 500 students. So each of these make up a different amount of their respective groups. So for example, math is 50 out of 100. So I can convert that to, all right, 50 out over 100. We know that's a nice fraction. That's about 0.5. 30 over 100 is about 0.3. And 20 over 100 is 0.2. Now, I'm going to do the same thing to my student sample. I'm going to convert these to relative proportions. 200 divided by 500, that's going to be about 0.4. And then 150 out of 500, 0.3 and 0.3. And now I'm just going to randomly assign some colors here. Let's say that math is red. English is, I actually don't even know, oh, green. And electives will be blue. Okay, so when I go to display these data, I now know how their plots work here. So again, I'm going to want to put a scale and my axes, some like that, and I'll put opinions on class preference, something like that. You know, give the title a little spice, why don't you? And like we said earlier, what sample size is larger? Well, my students, right? It's 500 students, 100 teachers. So how many times larger is this sample of students than the sample of teachers? It's a scale factor of 5. So when I draw my bars here, I'm going to have this one bar that represents my teachers. So I'm going to label that down here, my teachers. And because I interviewed 5 times as many students, in order to display that data, I'm going to just extend the bars out. So let's say I've got, all right, this one for students, this one for students, this one for students. As you can see, your teachers always love their students so much. And then for 5. So now, these 5 bars belong to the students. And we see it's because teachers, we only had 100 teachers, whereas students, we had 500 students. So the display for my students will be 5 times as larger than my display for teachers. So again, I'm going to make a scale here. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Okay, a little wonky, but again, you guys forgive me because you love me. So we've got our scale here. 10, 20, 30, 40, 50, 60, 80, 90, 100. Okay, so now that I have my relative proportions, I'm just going to shade that in. And again, you'd want to include your key. I already did the key up here, so I'm not going to do it again because I'm running out of room. But for my teachers, we know that 0.5 of teachers prefer math. So I would put the bar there at 0.5 for my mathletes, something like that. Whereas for my students, only 40% of the students sampled really preferred math. So I would put their bars down here. And again, see, we're still comparing the same type of categories, so the color is going to be the same, but I can see that a higher percentage of teachers preferred math compared to students. So that's how I can indicate the 0.5 versus the 0.4. However, if we look at the frequency, well, I know that 5 times whatever the sample size of this group here was preferred that same category. Not to say like 5 times 50 equals 250, but just saying like the student sample was 5 times larger than the teacher sample. Okay, next we go to English for teachers was 0.3. So again, here's my 0.5. I'm going to count up 0.3, 60, 70, 80. So that's for my English. And then for my students, English is another 0.3. So 0.4 to 0.3, 0.5, 0.6, 0.7. And then lastly, for my teachers, 0.2 remains for electives. And for students, 0.3 remains for electives. So again, we're just going to shade that in. So here's my English category. And then here is my elective category. I know, such beautiful pictures, right? I totally should have been an art teacher. But the Mosaic plot, again, is just still showing us the categorical data. The only difference is that the width of the bars are proportional to the sample sizes. So I can compare, right? I can see that a higher percentage of teachers preferred math than students. However, more students were sampled. And then 0.3 for English for both categories. So even though this bar looks a little bit higher, right, I would still have to check the width of the bars. So the same amount, the same relative proportion of teachers liked English was the same as the student preference. And then lastly, for electives, I had 0.2 here, but I had 0.3 here. So students had a higher preference for electives than teachers. So just remember, when we're comparing distributions, we just have to use comparative language. Larger than, similar to, less than, things like that.